All right, I want to do a video on the quiz you just took that covered finding derivatives using derivative rules from section 3.2. So pretty much you needed to know the power rule. Okay, you needed to know the rule for doing sine and cosine. And you needed to know how to handle the E. Okay, that's all that was in 3.2. Okay, so let's go ahead and go through this. So the big idea in 3.2 was for algebraic functions was that if you can write something as a power function, then you can use that power rule. And so when you have something like a polynomial, which is the sum or difference of power functions, you just, when you're asked to do the derivative, you just find the derivative of each term, and each term is a power function. So you bring down the exponent, do 4 times 3, then x to the 4, take away 1. Then you're going to have minus 2 times 3 times x to the 3 minus 1. And then the derivative of a constant we know is 0. So we wind up with 12x to the third minus 6x squared, and that's all there is to it. Okay? So that was a normal ordinary polynomial. So each term is a power function in the literal sense. Well, what you want to do on a problem like number 2 is you want to think about how you can rewrite it so it has the look and feel of a power function. So when we have that s to the fourth in the denominator there, we can rewrite that as s to the negative 4, can't we? So the r function really is the same as 3 halves s to the negative 4. So we're going to use that power rule to find the derivative. Bring the negative 4 down, multiply by the 3 halves, do s to the negative 4, take away 1. So that becomes negative 6s to the negative 5th power. And then since it started the way it did, and also with negative exponents, you really should always go one more step and rewrite it with positive exponents. That would be negative 6 over s to the 5th power. Remember that exponent's only being applied to the s, so only the s is going to move to the denominator. Okay? So I wanted to throw one more example in. You didn't have a quiz on this, but this was another function that you can change into something where you could apply the power rule. So this one has that radical, and I went ahead and put it in the denominator. But couldn't I rewrite that as 5 halves and then x raised to the negative 1/2 power? Then when I do the derivative, I can use the power rule and do negative 1/2 times the 5 halves times x, and then take 1 away from the exponent. So that would become negative 5/4 x to the negative 3 halves, because that's negative 1/2 minus 2 over 2. So that's negative 3 halves. And then I could rewrite that without that negative exponent and also put the radical back in eventually. So let me first get rid of the negative exponent. So that would be negative 5 over 4x to the 3 halves. And then x to the 3 halves, I could change back to a radical. It would be square root of x. And you can do it to the 3rd power underneath here, or the square root of x all raised to the 3rd power. Okay. All right, so I wanted to do that extra example because here we had, on number 2, we had a rational function. And then if I gave you one like this example, you have a radical in there. Both of those, by using just a little bit of algebra, you can turn it into a power function and just use the power rule. Okay. Now on number 3, this problem included the transcendental function. So you had cosine, you also had the e function in there. I had made a mistake and used x on the e, so I need to be careful about that. I don't think that caused anybody to miss it though. But I did change it back so it has a t. Okay, so I'm doing one of the 2 versions of that. So you can do it term by term, because when you're doing the derivative of the sum or difference of terms, you can do the derivative of each piece. And so when you go to do s prime, you take the derivative of t to the 3rd, and that would be 3t squared. when you do the derivative of cosine, it's negative sine t, but there was already a minus in front, right? So that's going to really become plus sine t in a minute. And then the derivative of 2e to the t is going to be 2e to the t. Okay, because the derivative of e to the t is e to the t, and when you have a constant out in front, you can just carry it along. All right, this is not a power function here. It has that look like it has an exponent, but you don't bring the t down in front or anything of that type. All right, now I'm just going to simplify it a touch by doing the opposite of negative sine t would be plus sine t, and then we have plus 2e to the t. Okay, and that would be the derivative of the original function. Okay. All right, now with questions 4 and 5, these were two more functions that maybe it looked like you couldn't do the power rule at first. Maybe it looked like you need to do the quotient rule on number 4, or on number 5, it looked like you had to do the product rule. Well, you could do those rules, but what you ought to do on a problem like that is to do a little bit of algebra first. See how this is a single term in the denominator? What you could do on that is just divide that into each term. So that t could get divided into each because it's a single term down there. Then simplify each term, writing it as a power rule. So see how this right here, one of these t's would cancel out. So you'd have 3 over t. So that would be 3t to the negative 1. And then here we have 7t to the negative 2. So there's a little algebra you could do first to change it so that you can apply the power rule. Now we're ready to do the derivative. 7t to the 6th minus 3t to the negative 2 minus 14t to the negative 3. And then you need to rewrite it because you have these negative exponents. So we wind up with 7t to the 6th, okay, minus 3 over t squared minus 14 over t to the 3rd. Okay. Now you could do this problem using the quotient rule, and some of you thought that's what you needed to do, or maybe you just like to do that. So let me do the other version using the quotient rule. So first way I did it was using algebra and to get it so I could use the power rule, right? And then the second way you could have done it is using the quotient rule. Okay. All right, so I'm going to just call this is my f function, this is my g function. So the quotient rule says when I want to do the derivative of this, I need to do the derivative of the top. Okay. So, and the derivative of the top would be 8t to the 7th plus 7 times the bottom function as is. Let me not do that. Okay, then minus the derivative of the bottom function times the top function as is. And then all of that gets divided by t squared, the denominator squared. Okay. So you sometimes see it, the rule low, d high, minus high, d low, over, right, high, over the low squared. All right, what's important is that you do the derivative of the numerator when you do that first chunk so that you get the minus sign going in the right spot. So you get the sign of the overall answer correct. Okay, so low d high minus high d low over the square of what's below is a little rhyme sometimes people use. Okay, for me, I remember that the derivative of the top function has to happen within this first group. Okay. All right, now we wind up then simplifying. So we'll distribute the t squared and get a t to the 9th plus 7t squared minus 2t to the 9th minus 14t squared minus 12t. and then all of that's over t to the fourth. Okay. All right, so then we notice we have some like terms that need to be combined. So we get a 6t to the ninth, then we get minus 7t squared, and then minus 12t, and we have this all over t to the fourth. Okay. Now these, remember the one I'm doing now is from the other version of the quiz. Okay. All right, so then when I simplify that, I'm going to wind up with, what do I have? I have I'm going to put it right over here. Okay. All right. So when I simplify that, and this is the derivative started right there, I'm going to divide t to the fourth into each. I could divide t to the fourth into each piece, or I could factor out a t and leave things in factored form. If I divided the t to the fourth into each, I have a 6t to the fifth minus 7 over t squared minus 12 over t to the third. So that's one version of the answer to it. So you could have done that using algebra and the power rule, or you could have just gone in and worked with the quotient rule. Okay. The intent was for you to do the easy algebra of dividing everything by t squared in order to create this so that you could then just do the derivative using the power rule. Okay. And that was the intent on number 5 also. You didn't need to use the product rule on that. The quickest way to do this, even when you know the power rule, is to just FOIL and rewrite this. So this would be 15x to the 10th minus 35x cubed plus 18x to the 7th minus 42. That's still y. And so when we now do the derivative, we just have to use the power rule. So we'll get 150 x to the 9th minus 105 x to the 2nd plus 126 x to the 6th, and then the derivative of negative 42 would be 0. Probably be better if we wrote it in descending order, but that's not something that you would be counted off for. Okay, so that's what you would do if you used a little bit of algebra first to try to tweak it so that you could use the power rule. Okay, now you could have done the product rule on that, and if you did, you take the derivative of one of them times the other plus the derivative of the other one times the first. Yikes. Let me move that over a little. So let me try that again. So when I do that one, I'm going to do derivative of one of them times the other plus the derivative of the other one times the first. And then just having to simplify by distributing the 6x squared, which would be 24x to the 9th minus 18x to the 2nd. And then I'd have plus 56x to the 9th. And then one more term I'm going to bring down on this next level, plus 4 times 28. So what is that? That's 8, 112 x to the 6th. Okay. Let me check that right there. 4 times the 28 would be 32. That would be 112 x to the 6, excuse me. Okay. All right. And so then I would wind up with 24 and 56 would be 80 x to the 9th. Then I'd have the 112 x to the 6th minus 18 x squared. Okay. All right. So with 3-2, you just got to get really good at being able to rewrite your expressions. Your goal should be to try to make it to where you can use the power rule if at all possible. Then if not, you go ahead and use the product or the quotient rule, which you learned in section 3.3. Okay. And then in 3.2, the only thing in that section that you learned for transcendental functions was just the basics: sine, cosine, and e. So the derivative of sine was sine, the derivative of cosine was negative sine, and then the derivative of e to the x is e to the x.